Yeah, welcome again, class. Today is June the 27th. I hope you've had a restful holiday. Uh,
Yes,
we are going to take on cluster analysis today. We'll have three presenters. We'll have Iroko starting. And if Kennedy is set at the time, we'll take Kennedy. If he's not set, we'll then take on the third person, and that way. So, Dr. Ganiyu Iroko, how are you doing?
I'm fine, sir.
Very good. Are you ready to roll?
Yes, sir.
Very good. So you have the floor. 8 minutes to make your presentation.
Okay, sir. Good evening, Prof. Sir. Good evening, my colleagues. I'm to present on cluster analysis. And in my presentation here, I have about 25 slides. And
Okay.
I'm starting with introduction. Please, let's move to slide 2.
Okay.
Now, the cluster analysis is an explorative analysis that tries to identify structures within the data. It is also called segmentation analysis or taxonomy analysis. Cluster analysis is used to identify groups of cases if the grouping is not previously known. What cluster analysis means is that it's all about finding observations which are similar. Now, but most specifically, it tries to identify homogeneous groups of cases. And what is that cases? That is your sample size. That is the observations, maybe observation, participants, respondents, or those that involve in your sampling. Let's move to chapter 3.
Is it
And let's
chapter?
move to, sorry, sir. Let's move to slide 3, sir.
Okay.
Now, let's look at this example. Which of the instructional materials used for teaching geometry are similar? We have the instructional materials labeled A to J, and then they have their make. Now look at instructional A, instructional materials A. It was made from paper, and the shape is rectangle. Let's look at J. It was made from wood, and the shape is rectangle. Now, as they are now, we want to cluster. We want to do the clustering. Now, if you separate them into groups, that is clustering. But
Okay.
those groups are called clusters. Now, let's move to slide 4. And
Yep.
you can see my drawings here. If we consider shape, as I said earlier on, we have two attributes in that example. The first attribute is make, and the second attribute is shape. Now let's consider shape. If you have shape, you can see the first one is triangle. How many instructional materials are of the shape of triangular shape? We have B, we have F, and we have H. It shows that between B, F, and H there is homogeneous. B, F, H, they are homogeneous. They are triangular in shape. And look at C, D, I. They are what? They are circle. And the AEG, they are what? Rectangle. That is, they are homogeneous. Each of them are homogeneous. BFH are homogeneous. CDI are homogeneous. And the AEJ are homogeneous. Let's look at make. If we consider make, look at ADEI. They are made of paper. That is homogeneous. There is homogeneous between the instructional materials. Let's look at BFJ. They are made of wood. There is homogeneous between them. And let's look at CJH. They are made of plastic. So that when you group them together, they should be homogeneous within the group. And each group should be quite distinct. It means that one group should be quite dissimilar to any other object of other groups. It means heterogeneous. What we have here is within the group we have homogeneity. But between the group, we have homogeneity. Between the group, we have heterogeneity. Now let's slide 5. And slide 5 represents what, as I said earlier on, within group, we have homogeneity. And then between group, we have heterogeneity. Let's move to, and look at this example now. We have 3 clusters. See, we have yellow, we have blue, and we have red. Each of these each of these clusters represent 3 groups that I mentioned earlier on. If you consider sheep, we have 3 clusters, and if you also consider milk, we have 3 clusters also. Let's move to slide 6. History. Now, cluster analysis was originated.
You have about 5 minutes, Iroko Gani. You have 5 minutes more.
Yes, thank you, sir. Cluster analysis was originated in anthropology by Driver and Prober in 1932. Let's move to slide 7. The mathematics model for cluster analysis is being shown here, and you can see you don't need to worry much on that. You will see how it works in SPSS. Let's move to slide 8. Now, the assumptions for using cluster analysis. We have normalcy of population, homogeneity of variance, random assignment, and mutually exclusive. That is, observation should not be in 2 places. It should be in one. Once you have one of the observation in any of the group, you don't need to repeat it in another group again. Then let's move to slide 9. Sequence of analysis. The cluster analysis is part of sequence of analysis. That is, we have factor analysis, cluster analysis, discriminant analysis. The factor analysis reduces the dimension, and therefore the number of variables makes it easier to run the cluster analysis. The factor analysis minimizes the effects, and the cluster analysis identifies the group, while discriminant analysis makes use of it of the model that the cluster analysis found and provides the cluster. Discriminant analysis follows a cluster analysis because the cluster analysis does not have any test of each measures or tests of significance. The cluster analysis relies on the discriminant analysis to check if the groups are statistically significant. If the variable significant is if the variable statistically discriminates between the groups.
You have 4 more minutes.
Let's look at this. A typical study. The effect of humor and the concept mapping on student performance. You know, in the first, in my first example,
Yes.
there was one. We have 2 attributes, and it has 2 dependent variables. That was why that can be said that there is no objective function. But here we have 3 groups, and look at the performance. We have about 3 variables there: the achievement, attitude, and the practical skill. I'm taking cognizance of the data used in the last EST 901 examination. Here, the attribute that we can cluster on is we have group, we have 3, we have human, we have concept mapping, and we have a conventional theory. So you can cluster on any of these. Let's move to the next slide, which is slide 11.
You have 3 more minutes.
Yes, let's move to slide 11. When we research question, when we examine student achievement, attitude, and practical skill, what do we consider to be homogeneous? Here, the researcher measures achievement, attitude, and practical skills. Now, a cluster analysis then identifies what homogeneous group exists among students. That is, whether a student do well in achievement and fail other, maybe practical skill and attitude. The analysis then provides this performance cluster and tell us
2 more minutes.
Yes, thank you. Let's look at how we can analyze our data using SPSS. If you want to analyze data, you want to perform cluster analysis using SPSS, the first thing is to copy it from Word, whether you have key in your data in Word or you write directly in SPSS. Then label them. After label, you move to analyze. From analyze, you move to classify. From classify, you go to the next direction. Yes, this is what we have in our SPSS. You can look at the image in slide 13. This is what you will have. After that, you move to from the classify. You see this. You move to method of cluster analysis. Cluster analysis gives 3 methods. K means cluster, hierarchical cluster, and two-step cluster. You can see it in that image. But for the purpose of this presentation, I choose to use a hierarchical cluster.
1 more minute. 1 more minute.
Hierarchical cluster is the most common used method. It takes time to calculate, but it generates a series of models with cluster solution. That is from the cases that you have, from 1 to the number of cases that you have. Hierarchical cluster also works with variables as opposed to cases. You can make use of cases or you make use of variables, as you can see there. Let's move to slide 16. From slide 16, we have Theodorem. You know what Theodorem does is this. Even before moving to that, we have statistical.
Okay, your time is up. Your time is up, Iroko. You have used your time very, very, very poorly. I'm completely dissatisfied with the way you use your time. We told you 8 minutes, and you spent a lot of time, most of the time, on what I can call noise. When that comes to the substance, because the time, this is the time, this is the portion of a presentation that, as far as I'm concerned, is the meat of it. So you just spent your time rambling on what I can call the first course. The main course, this is where we are. And I think you've been attending the seminars. You should be able to apportion your time. All these other ones that you said for the past 5 minutes, you just spend about 1 minute on them. And then focus on this. If you saw what Kennedy presented yesterday and what the others have been presenting, just straight to the point, and this is the heart of the matter. So I'm not happy about how you have used your time. And as I said, we're stopping you now, but I'm prepared to give you 1 more minute to go to that main course that you just failed to get to. So you have 1 more minute. And you see, I helped you by warning you 5 more minutes, 4 more minutes. I thought that you use that opportunity to now race, quicken your steps to get to the meat of this presentation. So that you didn't do, and I'm not delighted at all about it. So just conclude your presentation. I'll give you 1 more minute.
Now, thank you, sir. I said we are to use a hierarchical cluster. Now, it depends on what you have. You know, we have dendrogram. You know, dendrogram, we graphically show how the clusters are made and allows you to identify what the appropriate number of clusters you have. After that, let's move to slide 17. You know, we have cluster method. You can use the one that you like. We have between method, we have within. You can choose anyone. We have only word method has a value. Then to what to measure, we have interval. Move to slide 18. We have a interval and it has its options here, which you can choose anyone that you have. Let's move to slide 19. We have a counts. If you don't use an interval, you can use count. And in slide 20, you can use binary. And any of them. And the last one is standardized. What you want, whether you want standardized or not. And the lastly, this is the output from the cluster. What it will gives you as the result. This is what we have in slide 22, and you can also see it in slide 23. And if we move to slide 24, that is the conclusion. In the presentation, effort to present the most promising development in cluster analysis is given. Cluster analysis is still understood as a distributive technique whose results are dependent upon the effect of use method. Subsequent presentation will focus on how to interpret and report the output of cluster analysis using SPSS. Thank you very much, sir.
All right. Thank you, Iroko. You have done fairly well. You can see the applause from in the class. They are quite happy with you. You know what your strengths are, your deficiencies. You see that last slide, that conclusion that you said in the next presentation you'll be reporting on the interpretation of the output. That is what you are supposed to present today. You know, all those first 10 slides, you should just take them in 10 seconds, and then you'll have moved to this heart of the matter, and then give us the output and how it is to be interpreted. I'm sure that Kennedy, who is presenting next, will not fall into this trap. But meantime, let us open the floor for questions and Gbileyi, Igbokwe, Fakule in that order. Anyone that's able to come up.
Yes, good evening, sir.
Yes, good evening.
This one is on slide 6.
Yes.
I want him to throw light on the history, anthropology. I don't know, is that a country or where is that?
Yeah, they're saying anthropology is don't disgrace. Anthropology is a field of study. Okay, I'm not going to. I will assume that we have not had that question. Yes, Igbokwe. Fakule.
Good evening, class. Good evening, class.
Good evening.
Good evening, good evening.
I want to explain slide 9 very sir. Just talk about the difference between factor analysis and cluster analysis. Thank you.
All right. There's no need for anybody to be saying good evening, good evening. We are wasting the time. We already said good evening at the beginning of it. Just go ahead and ask your question. So, Fakule, Alabi.
Slide 8.
Yes, slide 8.
I want to ask if the parametric assumption are limited to all this, or we have any other one?
Okay, I think you asked the same question yesterday for the other person.
No, sir.
Oh, okay, that's fine. So this assumptions. Very good. Thank you, Alabi. We go on to Dr. Mary Olayoju. I already told the class that you'll be late because of your being caught in traffic here. Yeah, so let's take you. We'll take Samuel, and then Mary Adaje is still studying us. I'll move to Oyewuchi Francis. Yes, Mary Olayoju.
Yes, sir. Thank you, sir.
Pleasure.
My question is on the topic. I wouldn't know. It said in performance. Performance in what?
Okay.
I'm looking at the topic today, but yes, sir. The topic for the study.
Okay. So please note that, Iroko. Samuel. Francis.
Sir, yeah, slide 14.
Yes.
There are 3 methods out there. K means cluster, hierarchical cluster, and step cluster.
Sure.
Using I didn't use hierarchical cluster. I want to know why. Why didn't he use K means cluster?
Okay, very good question. Very good question. Yes, Joseph Amuide. Peter Agbetonyo.
It's just a
No, I've gone past you. Peter Agbetonyo. Larry. After Larry, then Stephen.
Yes, my question is on slide 8.
Yes, slide 8.
On slide 8, the fourth parametric assumptions, mutually exclusive. It's kind of new to me, sir.
Okay, he explained it, but he will re-explain it or offer better explanation. Last one, Stephen.
Prof, sir, I'm here, sir. I still have my
Slide 4
question, sir.
and 5. You talked about
Samuel, just listen. We have our rules in this class, so you don't just jump in. I've gone past you. Yes,
All right,
Stephen.
yes.
Yeah.
slide 4.5, you were talking about homogeneity within groups and heterogeneity of evolution between groups. So maybe you could clear the air for people to really understand when it's within groups and when it is between the groups.
Excellent. Okay, that's fine. Rahim, we can't see you. If you can hear us, can you hear us, Rahim? All right, Rahim is just trying to connect, but is not having success with that. So, Iroko, please answer the questions that you are able to answer.
Yes, sir. On slide 4 and 5, homogeneity and heterogeneity. You know, homogeneity is when something is homogeneous, when they have something that is similar. You know, what the attributes that we use to cluster, each of the group, there should be homogeneous. They should contain objects that are similar. And the heterogeneity is between the groups. None of the observation in each of the group should be in another group. Each observation should be peculiar to one group.
Yeah.
You should not have it and that explains mutually exclusive.
Okay. All right.
You should have it in one and have it in another one. You should have it in just only one group. On slide 8, parametric assumption. Enormity of population is general to parametric. I use the headline parametric assumption. I think these assumptions are for this cluster analysis because of that mutually exclusive. The first three, they are general for parametric assumptions, but that mutually exclusive is exclusive to cluster analysis. I'm sorry for the topic used.
Yeah, I think the question that Alabi asked you is this. Are these the only 4? Do we have some more? Or do you regard this as a major assumptions for cluster analysis?
These are the major assumptions.
Okay, that's the question that he asked you. All right, go ahead.
Yes, these are the major. And on slide 9, you know, as I said in my explanation, I said we have sequence. They are related. The three are related. You know, and I said cluster analysis doesn't have F value. If you can collect, it doesn't have F value. It depends on discriminant analysis to show whether it is statistically significant or not. I think I said it in explanation that the cluster identifies grouping and the discriminant. Now check the goodness of it, of the model that the cluster analysis found, whether it is statistically significant or not. And then the last one, I think that is on slide 14.
Yes.
And as Mr. Francis asked, why I choose hierarchical cluster.
Very good question.
Like, getting to a junction, and you have 3 paths to follow, and these 3 paths link to where you are going. You can follow any of these. So we have a hierarchical cluster, and then we have two-step cluster, and then you can use any of these that's related to what you are doing. Any of it. I think I answered.
All right, you have done very well, Gani Roko. Can we applaud him? Yes, he has. He's been exceptional, and we have almost like a full class today. Let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8. 16 people in class today. That's not bad at all. That's not bad. So we'll move on to the next presenter, and that's Kennedy. Kennedy, are you set? Sorry, I'm moving on. Kennedy, are you set?
Yes, sir.
Okay, that's fine. Okay, so class, I think since we cannot get Kennedy to come on, let us let's close the class, and we look forward till tomorrow when we'll take the other presenters. So until tomorrow, it is bye from me. Yeah, bye-bye, everybody. Bye-bye. Thank you. Thank you very much. Thank you.